Okay, so let's do practice quiz 12. Before doing that, let me give a brief lecture over one-way ANOVA. So the one-way analysis of variance, so ANOVA, is used to determine whether there are any statistically significant differences between the means of three or more independent groups. So the one-way ANOVA compares the means between the groups you are interested in and determines whether any of these means are statistically significantly different from each other. So the null hypothesis would be that all the means are the same, and the alternative hypothesis would be that at least two group means are statistically different from each other, significantly different. Okay, and you have some assumptions of the ANOVA, and that your populations follow a normal distribution, and the populations all have the same standard deviation, and they're randomly selected and independent of each other. Okay, so here's the R code for running an ANOVA test. We'll come back to that, like the template we'll be using. Okay, now let's go on to our question here. So it says you randomly select 30 individuals and then split the group into 3 subgroups of 10. All the group members are then asked to complete the same task. The time it takes each member to successfully complete the task is recorded. The first group members complete the task in silence. The second group members complete the task while loud heavy metal music plays in the background. And the third group completes the task while loud classical music plays in the background. Below shows the recorded data in seconds for each of the group members. So we basically have your 3 groups here. They all have 10 people in them. So the first group completes it in silence. Yeah. So for example, this is person 1 here. They complete the task in 50 seconds. Person 3, 70 seconds. Then group 2, they complete the task while heavy metal music is playing, loud heavy metal music. So the first person does it in 82 seconds. So forth, 75 seconds. And the third group is loud classical music. This person does it in 54, the first guy 60, and so forth. So here's our times of the groups. Okay, so we're going to use, so it says first state the null and alternative hypothesis, then write the R code that does the following. So let's first write our null and alternative. So our null would be that the means of all the groups are the same. So it doesn't make any difference whether you complete a task in silence or with loud heavy metal music playing or with loud classical music playing. And the alternative would be there are at least 2 group means that are statistically significantly different from each other. Okay, so now let's start. So to write the R code that does the ANOVA test. Okay, so let's take our template up here and paste it down here and make some changes to it. Okay, so let's put it down. Let's put it right here. Let's put it actually in the next page here. Yeah, I need my group stuff over here too, so I already have it pasted here, the groups. So let's put it below here. Okay, so looking at the template here, it says groups equals put control groups here. Okay, so the first group, group 1, has 10 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're going to have to repeat group 1. So take this away. So you're going to repeat this, group 1, in parentheses, 10 times. So let me pause the video and do that, and I'll come back. Okay, so you see I've repeated my G1 group 10 times. Now I have to do the same thing for G2 because there's 10 guys here. Also G2 guys, so let me repeat G2 10 times. So let me do that. So 1. So let me pause the video and I'll come back. Okay, so I've repeated the G2 guy 10 times there. And lastly, now I'm going to repeat the G3 guy 10 times. So let me pause the video and do that. Okay, so I repeated my G3 guide 10 times here. You can check. There's 10 of them. Then I have the parenthesis at the end and comma. Then we're going on to test results. Then it says put test result data here. Our test result data is these vectors. So this is going to be easier. So it's going to put G1, comma, G2, comma, G3. And take away the stuff then. Okay, so we're doing that part. So then this would do the ANOVA test here. Okay, so I guess we're done with part A. Now let's look at part B. So part B then creates box plots for each group and adds the mean. Okay, so let's do that next. Okay, so you want a box plot for each group. So the way you're going to do that here is you're going to use this. It's going to be box plot, then my data. So that's the data we have defined up here. Then you're taking the test. So the $ means take the test results. So test results are these numbers up here. And you're going to match them up with the groups. So then you're going to say, so we're going to match up the test results with the corresponding groups here. So this is the way you're going to have to type it on your quiz. Okay. So let's keep going then, and let's see what else it says up here for our directions. For B, okay, labels the main title as task times by group. Let's take that. So main title. Maybe just actually paste this guy below. We can get rid of it. Paste it down here. So task times by group, your main title. Okay, next we want to label the x-axis as groups, so it'll be xlab, and then groups. Or ylab wants it to be time to complete task. Oops. There. And then colors. Okay, we want the group 1 guide to be blue, so we're going to write blue first. Group 2 to be red, so you write red next. And group 3 to be green. I think that's it for the box plot then. Okay, let's keep going. Okay, so we still need to add the mean to each box plot. So we haven't done that yet. We got our box plot up here. And the way you'll do that is using this code here. So it's T apply in front, then my data, so looking at your test results, and this is saying find the mean of each of the groups, and then the points is pretty much adding the means to the box plot up here. So you just have to write this. Okay, so I think we're done with B now, so we can take away B here. Let's see what the next step is. Look at the P. So we need to run this now. Let's go to R and run it. So it starts here down to here. Okay, let's go to R. So R command. That's here. There it is. Okay. Okay, get rid of this. Okay, let's run our guy. Okay, so pasting our guy here, running it. Okay, so there's our groups all the way down there. Then we have some output, and we have our box plots here. So let's paste this at the bottom of our doc. That, and let's paste the box plots also. So you can see task times by group. So you got your group 1, group 2, group 3, and the black dots in here are representing the mean. The black line represents the median. Okay, so let's paste this guy into our guy too. So it looks like the middle one did the worst, I guess. Looks like group 1 and 3 pretty close, and group 1 was in silence, group 3 was with loud classical music, and group 2 was heavy metal. Okay, so let's go over here, let's paste it here. So now let's find our p-value. So the p-value, just take this stuff for now, bring it to the top here. So let's paste it below here. So the p-value here is this guy here. Let's take that. So write p-value equals this guy. And take this stuff away for now. Okay, so we found our p-value. So looking at this, looking at the question here, looking at the p-value from the R output, which we found is this guy. Decide whether any of the groups have mean times that are statistically significantly different from each other. Use alpha as 0.01 as your level of significance when coming to your conclusion. Write your findings at the top of your R code. So here's our findings here then. So looking at our output, we have our p-value is, as we said, this guy up here, and our alpha is 0.01. So our alpha is actually smaller than our p-value. Implies there is no statistically significant difference mean times to complete tasks by groups. That's based on our alpha is 0.01. If we had to change that to 0.05, then we have a different conclusion. So you can see that your conclusion is based on your level of significance. In this case, it's 0.01. So based on that level of significance, we can see there's not going to be a statistically significant difference in the mean times to complete a task by groups. But if you had to change that to 0.05, then we would have a different conclusion. Okay, but based on that one, we have our conclusion that there's no difference in the mean times. So we're done.